Good evening, students. If you are joined in the class, comment below, comment in that chat box. Good evening, Pooja. Good evening, Kurallarasu. Good evening. So in the last class, we have seen up to electric field due to the continuous charge distribution. Have you all remembered that? The linear area, the surface area, the volume. Have you all remember? We have already also find out the electric field for those terms. Have you all remember? Yes, very good. So today's class we are going to start from electric field lines. Okay, so today we are going to start from electric field lines. Okay, so these electric field lines are okay Kurallarasu, okay Pooja. So these electric field lines are the imaginary concept. Okay, these electric field lines are imaginary constant which is used to represent the electric field vectors. Okay, so these electric field lines are used to represent the electric field vectors. Okay, so it is having some properties. Okay, so consider the positive and negative charge, both are in the isolated system. Okay, so consider here is the positive charge and here is the negative charge, both are in the isolated system. Okay, so both will be separated for certain distance. Okay, so this positive charge will become radially outward. Okay, this positive charge field lines are directed toward the outward. Okay, this will be moves in the outward, represented in it will moves in the outward. The positive lines are radially outward and in these negative lines are radially inward. Okay, the negative lines are inward. Okay, so initially we have kept these two charges isolately. Okay, these two, what Anand Kumar? Good evening Anand Kumar. So initially these two charges were separated in the isolated system. Okay, so this positive charge, electric field lines in the positive charge will be radially outward. At the same time, electrical field lines of the negative charge is radially inward. Okay, so this is the first point. This will be the outward and this will be the inward. Okay, so initially we have considered both the charges were in isolated. Okay, so consider if the both charges are in the same system. Okay, so if the both charges are in the same system, means what will happen? The one electron will be escaped from this positive one. Okay, the one electron will be comes out from this system and this will attract that electron. Okay, did you understand? This electric field lines are radially outward, so the electrons will be comes out from the system and that electron will be, if the both charges are in the same system means. Okay, so if the both are in isolated, separated means the electrons will come out but it's not attracted by this one. Okay, but if the both were in the same system means the electrons will be repulsed from this system and this negative one will attract that electron. Okay, so likewise all the repulsive electrons will be attracted by this negative charge. Okay, so here we have considered positive and negative opposite charges. Okay, so if we are consider, did you understood up to this? Did you understood this electric field concept? So positive charges are radially outward, and whether the negative charges are inward. Okay, so the electron will be repulsed from this system and the electron will be attracted in this system. Okay, so if the positive and negative charge will be present in the same system, means obviously what will happen, this positive charge, the electrons will be repel from this positive charge. Okay, and that electron will be attracted by this negative charge. Okay, so if we consider the same like charges, means what will happen? So for example, I am considering the positive charge, both are positive charge here, correct? So here I am considering positive charge like charges in the same system. Okay, so what will happen? So from the both system the electron will be comes out, correct? So from the both system the electron will be repulsed. So from this one the electron will be comes like this, from this charge the electron will be come like this. Okay, but these two lines do not intersect. Okay, these two lines will not intersect, but it will goes like this. Okay, because both are repulsive, no, these two lines will be goes like this, they will not intersect, they will goes like this. Okay, did you understood? Have you all understood this concept? So the electric field lines, first we have considered the positive and negative charges in the separated system, isolated system. Okay, so if they are in the isolated system, means what will happen? Okay Kural, okay Pooja, okay. So if you have any doubt, ask me in the comment. Okay, don't hesitate to ask me the doubts to me. Okay. If the video and audio is not clear, means let me know. Okay, tell me in the comment, and also change the resolution setting. Okay ma? So if the audio and video is not clear, means tell me in the comment, and also check your resolution setting. Okay, and also if you have any doubts regarding our class schedule, means if you have any doubt, means already I have given the WhatsApp number, no? So just WhatsApp to this number, they will inform you clearly. Okay, so this is the WhatsApp number. So if you have any doubt, just WhatsApp to this number, you can get the clear information. Okay ma? Okay, did you understand this electric field lines concept? So positive, if we consider the positive and negative charge in the same system, means what will happen? The electron will be repulsed from the positive system, and the negative, and that electron will be attracted by the negative system. Okay, if the both are same like charges, means what will happen? They do not intersect, they will repulse each other. Okay, they will repulse each other. Okay, so and one more thing, so consider, okay, I will rub this and write it next points here. So still if you have any doubt in these points means tell me in the comment. I will repeat it once again. Okay. So consider this is the positive charge and these are the electric field lines. So here I have considering the lot of electric field lines which is radially. Positive means it is radially outward. Okay. So positive means it will radially outward. Okay. So consider if here is the, so consider here is one box we have considering. So same size box we have considering here space. Okay. So here we have consider a certain area and here also I am going to consider a certain area same as this one. Okay. So what will happen? What you can see here, the electric field lines are large here. Okay. But whether the electric field lines are small here, correct? Here it is having 1, 2, 3, 4, nearly 5. Here it is having the 5 electric field lines, whether it is having the 2 electric field lines here. Okay. So the intensity, if the intensity is increased, the electric field lines will be closer. If the electric field lines are closer means the intensity is high. Okay. So if the electric field lines are less, electric field lines are less in the sense which is apart. Okay. Then what will happen? The intensity will be less, which means which is decreasing. Okay. So see here we have considering this box, this area and this area, both the areas are same. Okay. So when we consider if the electric field lines are closer, the intensity will be the high. Okay. So when we increasing the distance, what will happen? The intensity will be decreased. So from the electric field we have increasing the distance. So this area is closer to the electric field. So intensity is higher and also the electric field lines are also high and closer, much closer. Okay. So when we take the apart electric field line, what will happen? The intensity will also, the intensity is decreasing and also what will happen? The electric field lines also decreasing. Okay. Have you all understood? Shall we move on to the next one? Shall we move on to the next one? So if you have any doubt in this, ask me in the comment. So if you have any doubt, tell me in the comment. Okay, we will move on to the next one, and if you have any doubt, okay, Kurala Rasu, okay, Puja, okay, good. So this is the problem. Which of the following represents the electric field lines due to a combination of two negative charges? So tell me the answer in the comment. So which of the following is the, which of the following represents the electric field lines due to the combination of two negative charges? Excuse me. You don't know the answer? Very simple question only, no? Kartika. So I will tell. So both are which of the following represents the electric field lines due to two negative charges. Okay, so see here, here is the one negative charge, here is the one negative charge. So this is the answer. Okay, we already know that both same charges will repulse each other. We have seen in the example positive charges. Here they have given the negative charges, correct? So both will repulse, so this will not come and this will not come, this will not come. So answer D is the correct answer. Okay, did you understood? So negative charge, like charges will repel each other, correct? Like charge will repel each other. Am I audible to you? Am I audible to you? Okay, okay, did you understood? Did you understood this problem? Shall we move on to the next one? So this is the next question. Which of the following figure correctly shows the top view sketch of the electric field lines of uniformly charged hollow cylinder as shown in figure? So which is the answer for this one? If you know answer, tell me in the current comment. Okay, if you also don't know means just let me know. So if you don't know the answer means tell me in the chat box. Okay, so this is the, so here they have asking the top view sketch of the electric field lines. So when we here see here, all this cylinder contains all positive charges. Okay, we know that the positive charges will radially outward, correct? The positive charges are radially outward. So what will be the answer? Which one will represent the outward? So option B is the answer. Okay, option B is the answer. Okay, did you understood? Shall we move on to the next one? Shall we move on to the next concept, or do you have any doubt in this concept? If you have any doubt, ask me in the comment. Just interact with the comment, ma, then only I can know, you will understand whether you are understanding it or not. Okay. Okay, Pooja. Remaining Anand Kumar, Kural Arasu, what happened to you all? What are you doing? So the next concept is electric dipole. Okay. So the electric dipole is nothing but two opposite charges will be separated by the certain distance is known as the electric dipole. Okay. Okay, Kuralaras. Okay. So two equal and opposite charges will be separated by the certain distance is known as the electric dipole. Okay. So consider, so here is the positive Q and here is the negative Q, and these two will be separated by the certain distance is known as the electric field line. Okay, this is known as the electric field line. So when we taken the center point from these two charges, okay, so when we take die, in the question itself we know that die means 2. Okay, so the two equal and opposite charges will be separated by the certain distance is called as electric dipole. Okay, so when we take the center point, so it is from the center point, the distance between the center point and the plus Q will be A, and the distance between the center point and this minus Q will be A. Okay, so the total distance will be 2A. Okay, did you understood? So 2 point charges, two equal and opposite point charges will be separated by certain distance. So from the center to till the plus Q, the distance will be A, and likewise from the center and minus Q, the distance will be A. So the total distance between these 2 point charges will be equal to 2A. Okay, did you understood? So this is the definition for electric dipole. Okay. So now I am going to find out the electric total dipole moment. Okay, dipole moment. Total dipole moment. So consider, so we know that this is plus Q and this will be the minus Q, and which is separating by the 2A distance. Okay, consider if this will have the unit vector r vector and this will have the unit vector r vector. Okay, both charges will have the unit vector r vector. Okay, so when we will represent the electric dipole moment in the term of p vector. Okay, so p vector will be equal to, when we take if we take plus Q to minus Q, means the p vector will be equal to plus Q r vector plus minus Q r vector. Did you understood? This plus Q is represent plus Q and this is the minus Q, so minus Q r vector, which is equal to plus Q into, this is having the distance A, so AI minus QAI. So I have taken this minus in the outside. Okay, so I have taken this minus in the outside. Okay, so consider, and also see here, this minus will represent the negative Q. Okay, this minus is representing the negative minus Q. Okay, so see here, we consider this AI from here to here and here to here, both are in the opposite direction, correct? So here this will having the minus AI, this I will represent this line, we have considered this line in the x-axis alone, correct? So the coordinate for the x-axis is I. Which one I want to repeat, Pooja? Which one, Pooja? Which one, ma? I cap. So P vector will be equal to 2a q I vector. I cap. Okay, so listen Pooja, I will repeat it once again. Okay Pooja, so here we know that electric dipole is nothing but equal and opposite point charges will be separated by certain distance. Okay, so the from center till this plus q we have taken as distance a, at the same time plus center to the minus q as a. Okay, so the total distance is 2a. Okay, so here we are going to find out the total dipole moment. Okay, so we will represent the dipole moment as p vector. Okay, so here we are going to consider r vector, and r vector are the position vector. R vector and r vector are their position vectors. Okay, here we have taken the x-axis alone, correct? So here is the r vector and here is also the r vector. First, if we want to find out the total dipole momentum, we should add these two charges. Okay, so plus q into r vector plus minus of q r vector. Okay, so the plus q is represents the plus q and this minus q r vector represents this one. Okay, so for the r vector we will take the distance into that coordinate I, because we have considered the x-axis alone, correct? So a into I cap minus of q into, when we take this term, so we have considered this center to q and we have considered this center to q, correct? Okay, so the both will having the opposite direction, so we have minus a I cap here. Okay, so plus minus into minus plus, so the total dipole momentum formula is plus 2a q I. Okay, okay da. So if we take here minus q and here plus q means the positive, if we interchange plus q as minus q and minus q as plus q means what will happen? The total dipole moment will be equal to minus 2a q I cap. Okay, okay Pooja, did you understood? So if we take plus q as minus q and minus q as plus q means the total dipole moment will be equal to minus 2a q I cap. Okay Shiny, okay Shiny, have you all understood Shiny? Up to this topic have you understood? Have you all understood this electric dipole concept? Have you all understood this one? Shall we move on to the next one, or still do you have any doubt? So if you have any doubt, tell me. Okay Shiny, okay. Pooja Kural, okay Pooja Kural Arasu, Anand Kumar. Yes Anand Kumar, have you all understood? Still if you have any doubt, tell me. Okay Haja, okay. So the next one is the electric field due to a dipole. Okay, so here we are going to see about two cases. In the first case, okay Haja, electric field due to an electric dipole at points on the axial lines. Okay, and the axial lines, and the next case we will see the points on the equatorial line. Okay, so consider take here is the minus q and here is the plus q. Okay, consider this is point A and this is point B. Okay, so and a point C is located in the certain distance from the center. So consider this is the point O and this is point C Okay, so this point C is separated from this O by the by the distance R. Okay, so this point C is separated from this center O by the distance R. Okay, so from this midpoint, so this is the midpoint. Okay, yes, Shiny, yes, we will see, correct Shiny, we will see in the next topic. Okay, so see here we have considered the dipole A and B, which is minus Q and plus Q, which is the center of these A and B is O point. Okay, so we have considered the axial line which is C. So this is separated from the center point, this midpoint, by the distance R. Okay, so this will, the distance between this A and O is A, O and B is A. Okay, so the distance between the O and C is R. Okay, so we know that it will have the dipole moment P vector, which is equal to 2AQ. Okay, so we have already seen the electric dipole will have the dipole moment of 2AQ, correct. So we have C here, the electric field will be the, here it is having, it will have the positive electric field, and here it will have the negative electric field. Okay, because both are in the opposite direction, no, so it will have the positive electric field and it is having the negative electric field. Okay, so we have, first we have consider point A, point B, and from that we have draw the imaginary line, that means the auxiliary line C point. So it will have the both attraction and repulsion. So here it is plus E and here it is minus E. Okay, so this plus E will represents the repulsion and this minus E represents the attraction, because positive Q is near to this one, no, so this will experience the attractive force here, this both are will experience the repulsive force here. Okay, so now we will take, so now we are going to consider the electric field at a point C due to this positive Q. Okay, so electric field at point C due to this positive Q. Okay, so electric field at C due to positive Q. Okay, so we will get E vector, E plus vector, because here we have considered the positive one. So E plus vector equal to 1 by 4 pi epsilon naught Q divided by R minus A the whole squared. Okay, why I have wrote the R minus A? Did you understood why I have write R minus A? So see here, we should write the distance between this Q point and this C point. So the distance between this midpoint and the C is R, and the O point and B point is A. So I have just subtracted R minus A. So if we subtract R minus A, we can get the distance between B and C. Okay, so this is BC direction, along BC. So this will represents along BC. Okay, so next one, the electric field lines. First one, we have considered the electric field lines from the positive one. Okay, positive Q, and the next one from the negative, we can write E minus vector 1 by 4 pi epsilon naught Q divided by R plus A the whole squared. Here it will have the P cap and it is having the P cap. This P cap will represents the what? Unit vector. Okay. Yes, Shiny, based on this one they will ask the question problems. Okay, we will see the problems based on this one in the upcoming classes. Okay, Shiny, so based on this one they will ask the problems. Okay, Shiny. So for the, if we take for E minus, we can get 1 by 4 pi. For this one, we can get 1 by 4 pi epsilon naught Q divided by R plus A the whole squared into P cap. Okay. So when we find the total electric field, what we will do? We generally add the two. Okay, so E total will be equal to E plus vector plus E minus vector. So in the both term, 1 by 4 pi epsilon naught is the constant value, so take it out. So we can get Q divided by R minus A the whole squared minus, it will have the minus, okay, because this Q is minus, no, so minus Q divided by R plus A the whole squared into P cap. Okay, so when we solve this, we can get 1 by 4 pi epsilon naught. Q is also the constant, so take it out. Q by 4 pi epsilon naught. So here we should take the LCM. So when you take the LCM, you can get the answer 4AR divided by R squared minus A squared the whole squared into P cap. Okay, so when we take the LCM, oh, you can't see this line now, so I will write it down. I will directly, so take this Q value is constant, so take it out. So take the LCM, so you can get Q by 4 pi epsilon naught into 4AR divided by R squared minus A squared the whole squared into P cap. Okay, so did you understood? So you should just know the final value of the given situation. Okay, that is important in the point of NEET. Okay, in the NEET point of view, you should just know the final value, final concept of the given situation. Okay, that is very important. Based on this concept only you will do the problems. Okay ma, so here I am going to consider, see here the R value is much greater than A value, correct? So here we are going to neglect the A value, so we can get E total will be equal to neglect A value, so we can get Q by 4 pi epsilon naught 4AR divided by R power 4 into P cap. Okay, so here 3 and 1, so we will get Q by 4 pi epsilon naught 4A divided by R cube into P cap. Okay, so we have already know that P vector which is equal to 2AQ into P cap. Okay, so from this we can write as total dipole momentum, no? So we get 2P vector divided by 4 pi epsilon naught R cube. Okay, did you understood? This final value is important when we consider the axial line. Okay, the final value, this is the final value and this is the important one. So we will, in the upcoming classes, we will solve the problem based on this type. Okay, we will solve the problem based on this one, then you can understood it clearly. Okay, have you all understood? So this E vector will be equal to 2P vector divided by 4 pi epsilon naught R cube. Okay, have you all understood? Shall we move on to the next one? Have you all understood, Amma? Okay, Shiny, okay, okay, Pooja, okay. What about Haja, Shiny? Haja, video is not clear. Just check your resolution, Haja, okay. Okay, Haja, okay, Shiny, okay, good. So the next one is equatorial plane. Okay, so the electric field due to an electric dipole at a point of equatorial plane. Okay, so here we are going to consider a point. See here, So this is the dipole, electric dipole, and here we are going to consider a point. Okay Haja, okay, good. So the both will be, so here we are going to consider a point here, and this point will be separated by the distance r. Okay, in the from the midpoint, this is the midpoint O. From the midpoint, this point is separated by the distance r. Okay, so the total distance between minus q and plus q is, we already know, 2a. So this is a point, this is b point. Consider this as the c point. Okay, so here r is the equatorial distance. Okay, r is the equatorial distance, and the distance between the plus q and minus q is 2a. Okay, okay Raga Kirtana, I will try to take. Okay Raga, okay. So and also if you have any doubt regarding any in the class, means just contact that WhatsApp number I have already given, no, 9566073776. Okay, so just WhatsApp to this number. They will inform you clearly about the class details and the test, about the test details also. Okay, they will inform you clearly about the class schedule. Okay ma'am, so note it down the number. So here what we are going to do, so here we are going to resolve the electric field in the Haja, just WhatsApp to this number, they will inform you ma. Okay Haja, just once WhatsApp to this number, they will inform you about the class schedule. Okay Haja, okay da. So now we are going to resolve. So here in this point, this will have the E total. Okay, so when we resolved it, we can get it is plus E cos theta, and in this direction minus E cos theta. Okay, so for the sin theta, this is minus E sin theta. In the vertically upward, this is plus E sin theta. Okay, so this plus E sin theta and minus E sin theta lies in the perpendicular line, so they will cancel each other. So we can just consider minus E cos theta and plus E cos theta. Okay, so we know that electric field value is 1 by 4 pi epsilon naught Q divided by R square. Okay, so E total will be equal to E plus plus E minus. Okay, so here we are going to consider just cos theta alone. So minus E plus cos theta P cap minus E minus cos theta P cap. Okay, so E plus, this one is E plus cos theta P cap and E minus cos theta P cap, both are in the negative side. So when we consider the graph, what will happen? This will be the positive side, this will be the negative side, no? So both are will having the negative sign. Okay, so the modulus E plus equal to E minus. When we consider the modulus, what will happen? The negative signs will not present. So 1 by 4 pi epsilon naught Q divided by, so here consider, we know we should write the distance between the points, correct? So here what is the distance between this A and C point? We don't know. So just write BC squared or AC squared. Okay, so here we should write the distance between the ARC or BRC. Okay, so just write the BC squared or AC squared. So we will going to find out. Okay, so in the max we know that. So if we consider the BC squared, So if we take the BC squared, so this is the hypotenuse side. So hypotenuse side which is equal to hypotenuse squared which is equal to adjacent squared plus opposite squared. Did you learn this formula? So adjacent squared. What is the adjacent squared here? So the adjacent value is OA, which is A squared. The opposite side here is R squared. Okay, so the BC squared will be equal to A squared plus R squared. So instead of BC squared, we will just substitute the A squared plus R squared. So 1 by 4 pi epsilon naught Q divided by S Raga Kirtana, correct, very good. R squared plus A squared. So I will rub this WhatsApp number, just note it down. Okay. So 1 by 4 pi epsilon naught Q divided by R squared plus A squared. So now I am going to substitute this value here. So E total will be equal to minus 1 by 4 pi epsilon naught Q divided by R squared plus A squared into cos theta P cap minus 1 by 4 pi epsilon naught Q divided by R squared plus A squared into cos theta P theta. Cos theta P cap. Cos theta P cap. Okay. So just take out the constant values in the outside. So both are same terms, no? So just add these two terms. So we can get minus 2q cos theta P cap divided by 4 pi epsilon naught R squared plus A squared. Okay, so from this triangle we know that cos theta formula. So from this formula we can take cos theta which is equal to adjacent divided by hypotenuse. So when we take the theta value, the adjacent value here is A. So when we take the theta value here, the adjacent side is A divided by hypotenuse side is, we know that A squared plus R squared. Okay, so when we take the adjacent is A, adjacent side, when we take the theta here, the adjacent side is A divided by hypotenuse, we have find out no A squared plus R squared. So just we have substitute. So just we are going to substitute here. Okay, 2q, instead of cos theta we are going to substitute A divided by 4 pi epsilon naught. So this is the square value, but we don't have square, so root. Okay, so A divided by R squared plus A squared the whole power 3 by 2 into P cap. Did you understood? So here it is R squared plus A squared and here it is having the root. So just we have taken it as 3 by 2. Okay. So this is the power 1, this is the power half. Just we have just added these two. Okay. So these three terms we know that P value, correct? These three terms we know that. Okay, Mohammed, the class is going to finish soon. Okay, from next class try to be on time for the class. Okay, so when we know that the value for this P vector, so 1 by 4 pi epsilon naught minus 1 by 4 pi epsilon naught P vector divided by R squared plus A squared the whole power 3 by 2. Okay, so like the previous case, the R is greater than A. So neglect this A term. We can get E total which is equal to minus 1 by 4 pi epsilon naught P vector divided by R cube. Okay, Mohammed. So this is the answer. So this is the electric field value for the point, dipole point, which is at the equatorial plane. Okay, did you understood? Or do you have any doubt? So if you have any doubt, tell me in the comment. So the class is over today. We will wind up the session today. So from the next class, try to be on time for the class. In the upcoming classes, we will see the lot of problems based on the NEET point of view. Okay, ma? Okay, Haja. Okay. Okay, very good, very good. So we will wind up the class today. Okay, ma? Thank you, ma. Okay, Pooja.